Welcome back. We now know that the event loop is a piece of code in libuv that processes asynchronous events. It handles our asynchronous code, going through any relevant asynchronous callback functions in a loop. Node automatically enters this loop when it starts executing your code, and it exits automatically when there are no more functions to perform. So what exactly happens when the event loop processes events? When Node executes an asynchronous function, say setTimeout or our file system function to read a file on our machine, that operation is sent off to be executed in the background. As we've learned, this operation is executed in our operating system or on the thread pool. When that operation finishes and the result is ready, Node places any callback functions that it needs to run for that operation onto a queue. Say our asynchronous operation was this setTimeout that waits for 1 second before attempting to call a callback that we're going to call callback1. What happens is that when this timer expires, when 1 second has passed, our callback is added to this queue to be executed as soon as possible. This is true for any callback that you've set to be run when some asynchronous operation completes. These callbacks are put on something called a callback queue. This callback queue keeps track of which callbacks are ready to be executed. Any new callback functions are pushed onto the queue in this order. So another setTimeout that completes immediately after our first one would add its callback immediately after. And if we had a third operation complete with a third callback ready to execute, its callback might be added to the queue as well. So new callbacks are added in this direction from the bottom, and they're removed from the queue. They're executed from the top in this order, with callback1 being executed before callback2. This is what's known as a first-in, first-out queue. The first function to be put in, callback1, is the first to be executed, because it was the first one to be pushed into that queue. This queue is like a waiting area for our callbacks, where the oldest function, the one that's been waiting longest, will be the one to get processed by our event loop first when it has a chance. We use this queue system so that all your callback functions get a fair chance to be executed in a reasonable amount of time without interrupting each other. There we go. I've probably said callback and queue a million times in the past couple minutes, but the next video is going to be a really good one. Let's find out exactly how the event loop uses this idea of a callback queue. Oh, and by the way, you may have heard the term event queue or message queue being thrown around in the context of the event loop. These are just different names that refer to the same thing. They all refer to this idea of a queue of callbacks. All right, on to the next video.